Okay, so I'll be explaining here Kirchhoff's law. Alright, to start with, let us draw a circuit. So I have here my is a symbol of a conductor or wire. Then my positive terminal of a cell. So if it's a battery, then there should be two or more cells. Let me assign a value here of 10 volts. Okay. Now, a wire again, beniform. It can be wavy, it can be straight. That's a wire. But for formality's sake, let me just draw a straight wire here. Okay. Here I have my resistor. Okay. And another resistor. And another resistor. Okay. Alright. Let us start with a simpler circuit. Okay, let's just have three resistors and let me label them as R1, R2, and R3. Let's say, for example, that R1 is, let me just write it here. R1 is 2 ohms, R2 is 3 ohms, and R3 is 5 ohms. Okay, now we will analyze where does current flow through every resistor. Let me repeat that. We will analyze the direction of the current that flows through each resistor. So starting with R1 coming out from the voltage source, so this is I1. Because it's R1, so we'll label the current flowing through it as I1. And then this is I3. And this is I2. Take note that all currents must be going into one direction in terms of returning back to the power source. So I1 here, as we can see, will be divided into two. One will be going through R3 and another will be going through R2. So therefore we can create an equation, and this is actually Kirchhoff's law. Let us assign this junction here and call it node A. So KCL at node A. Again, that is I1 is equivalent to I2 and I3. Okay, so what if let's check our understanding if in a different circuit we can still come up or analyze what equation can be formed using KCL. Okay, say for example, this will now be the circuit again. This is the IEC symbol for conductor, positive terminal of the cell, negative terminal, and since there are two, so that forms a battery. And here a resistor, two resistors in series, and one resistor here and another one here. Okay, so let me assign the values here as R1, R2, R3, R4, and R5. Well, let me just say so that it would be more chronological to see. Okay, all right. You try to build the equations of current at node. Let us call this node A again for the circuit and see whether we come up with a similar equation. Let's say this is 10 volts. Okay, I will assign values first. So KCL at node A, the equation that we come up. Let us draw first the currents label. Okay, so this is I1. Alright, this is I2, which is equal to I3, because they are series. Remember the principle. The currents flowing, the current flowing through two resistors in series, currents flowing through resistors in series are equal. So this is equal as well. I4 equals I5. So I can create this equation. With this analysis, I would have this equation as well. I1 equals I2 plus I4. Okay. Or I1 equals I3 plus I5. Did you get it right? Okay. That's it for now.